Hello and welcome to episode 3 of the Plastic Collisions podcast, coming at you from the deepest, darkest corners of our minds. Today I am joined by Srideep and from inside the matrix itself, Suji.
Hi everyone.
Hi Suji, how are things down there?
Yeah, man. A lot of bad things are happening inside the matrix.
Oh, have you become the one yet?
Okay,
Soon. I'm on the journey. I'll reach there soon.
on the journey. Yeah. So, a quick
Yes.
reminder before we go into the episode, this podcast is available on all podcasting platforms like Google Podcast, Apple Podcast, Pocket Cast, Spotify, and all those platforms. It's also available in video format on YouTube. So, go there, go to all those places, like, share, subscribe, do all those things. With that out of the way, I'm going to turn it to Srideep
Yeah.
for today's episode.
So today we have quite a special episode. In the previous one about social media, we discussed about how they use various models and algorithms to present ads and various content to the user. And we promised that we'd go deeper into this topic. And today we have a friend, Hari, who is pursuing his PhD in computer science and works with machine learning techniques applied to images. Hi, Hari.
Yeah, hi guys. Good to be here.
Yeah. He is one of our closest friends, and we've known him for quite a long time since college. And considering the topic, he seems like a good fit for us to pick his brains about machine learning and AI. We don't think we'll go too deep into the technical aspects, but let's see where the journey takes us. We will primarily try to focus on what it is and how it would affect, or it rather affects our lives. And hope you guys and as well as we do get a better understanding of this at the end of our episode. So yeah, let's get down to it.
Could you tell the listeners like more about what you're doing and what your research is about?
Yeah, so my research is related to applying machine learning to images, and my the topic is called attentive and disentangled representation learning. I know that it's a
Too much.
bunch of fancy words.
That's a mouthful.
Yeah, but that's that. So it's basically about learning some representation, some compact representation for images, which you can use to search for similar images in a big database. For example, maybe you want to search for all images which are foggy in a data set. So you can maybe use one of the foggy images as a query image and then search for more such images from a data set. So I'm trying to develop a
Is
method to
this
achieve that.
is this something similar to reverse image search that Google has?
Yeah, it is. It is kind of similar to that, but the focus for me is on some specific aspect of the image. Whereas on Google, I think it searches for exactly similar images. Whereas here, I don't want to search for exactly similar images. I just want to search for images which have a certain property.
Yeah, but that
And okay,
is
so what
similar
do you
to Google Images though, right? Like in Google Photos, for example, if you search for lamppost,
Yeah.
it'll show every single thing that could look like a lamppost or is a light kind of thing.
Yeah, but if suppose this lamppost is from a specific place in the US,
Hmm.
then it's going to definitely find something which looks exactly similar first.
Okay, it'll prioritize
Yeah,
exact
it's going
matches
to,
first.
yeah. Whereas my research is more focused on just finding something more abstract, focusing on the lamppost and not just where it is or in which kind of a situation it is.
Okay,
so just
I'm
one
not
last
very
For
clear
question.
about it.
example,
Yeah.
yeah, for example, say you want lampposts from any time of day, whereas on Google Images, say if you search with the lamppost from the nighttime, then it's going to just find lampposts from nighttime because the rest of the image is going to be dark.
Okay. I haven't searched lamppost. I should probably check this out.
Yeah, so basically the idea is Google is going to take the entire image into consideration for searching,
Hmm.
whereas I want to focus on certain part of the image.
Yeah, Suji, you're
Mm,
gonna ask something.
yeah, so just one last question, probably before we move on. So,
Sure.
is the data that you use for this just from the image itself, or do you just go into the metadata of the image, take some information that is present over there, or is it just based on the pixels?
No, it is just based on the pixels. I don't use any metadata.
No, okay. So if it's going to be a lamppost, say in how would you in that case differentiate a lamppost or say a traffic signal in US versus a traffic signal in say India?
Yeah, so I don't manually do this. This is being automatically learned by some machine learning model. So the
Hmm.
machine learning
Okay.
model is going to learn different objects which are present in images.
Hmm.
And if the lampposts in the US and India are so different, then it's going to learn them as different objects. And if they are maybe quite similar, then it's going to learn them as the same object.
So you mentioned that the machine learning model is going to learn all these things. Right? It's going to learn a lamppost from US and then try to differentiate it from a different lamppost. What is going on in there? Like, what is machine learning? What does it learn, or how does it learn? Could you explain a bit, like some basic idea? Give us a basic idea about that.
Yeah, so let's start with understanding machine learning first. A
Yeah.
machine learning model is basically it takes some input data, which are some features or some kind of data which you have collected before, and it uses this data to identify some patterns in the data and learns some characteristics of this data in order to make some predictions, which can be, say, the weather tomorrow. So maybe to give an intuitive example, say you're just a normal person who has no idea about football. So you're on a football field and you need to score a goal. Now, the first time you're maybe not going to score the goal. You're going to maybe try to kick the ball somewhere. It's going to go somewhere not close to the goal. And the next time you're going to understand
Happens.
whether, yeah, you're going to update your the action that you did. You're going to maybe reduce or increase the force that you applied, adjust the angle in which you kick the ball, and then you're going to maybe get closer and closer to the goal, and then finally after many attempts you're going to score the goal. So this is what a machine learning model is also doing. It has some parameters which it uses to make the predictions, and it's going to keep updating these parameters until it gets better at making the prediction.
Okay. Hari, I have a question based on this analogy. So, being like a player person who plays football myself, so I remember the way I learned it, right? So there are two things that I did. One was to look at other people who actually were playing and try to do what they were doing. The other thing I was doing was I'll keep trying out some things on my own until something comes out which is something that I can use in a game. So is there like a distinction like this in with respect to machine learning models also, when you said that a model is something that learns how to do a certain process?
Yeah, I think the first example that you told about looking at other people and learning from them, that falls under the category of supervised machine learning, where you have
Okay.
collected some data and you're learning from that data.
Hmm.
Whereas the second example that you gave about you trying yourself, figuring it out, is more similar to maybe reinforcement learning, where you do some action and then you get some feedback about this action and then you update the model. This is the kind of method that they use to train these models to play AlphaGo and things like that.
Okay.
Okay.
So I heard that there is a particular AI that plays Dota. Does that
Yeah,
follow this logic that you've been
yeah,
telling?
yeah. I think it first learns from human data, human player data.
Okay.
Hmm.
So it's a bit mix of both. It starts with
Ah.
the supervised learning, and then afterwards it does reinforcement learning to improve.
So yeah, that was my question. Like whether it is always one or the other, or is going to be a combination of both, supervised and reinforced, like you mentioned. So
Yeah,
you're saying it's very similar to how we learn things, how humans learn different things, right? I personally, based on your example, I can also I also have a similar example. This past week, I've been trying to do some cooking, and I tried to recreate my mother's chicken gravy recipe. So to do that, what I did is I wrote down the list of ingredients, and I wrote down the list of steps. And during the process, one of the key things that we have to do is keep tasting what we are cooking, so that we know if the flavors are balanced or not. And in this particular case, there was some imbalance and there was some blandness also. So I had to go back and modify the steps that I perform, and maybe add some steps like add chili powder, salt, pepper, and all these things in order to make the flavors balanced, right? So this way I can like very much compare it to like what you say as an algorithm, which has a set of inputs, and with these inputs, it kind of does some manipulations and then gives an output. And once we see the accuracy of the output, the algorithm goes back and changes the steps that it performed. Maybe it adds new steps, or maybe it removes some steps or alters existing steps and gives a better improved result. And over the course of multiple iterations, maybe it kind of improves this result to a certain level of accuracy, right? That is what I am trying to like understand. That's what I understand from what you example you gave. Like, is that a correct way of understanding how machine learning works, or is it more than this?
Yes, I think that's a very good analogy to understand how machine learning works. That's exactly how
Okay.
things work in many of the models.
Okay,
So
but
in this
yeah,
case, yeah, go ahead.
no, I was going to ask like, yeah, the machine learning, you said that it will train or do some processes, algorithms or whatever, and it will try to make itself tend towards the prediction that is more accurate. But does it know on its own that it is getting more accurate, or does someone have to tell them, okay, you're wrong, you're right, and then do something to make it more accurate or fix some things?
Yeah, so this comes from the data that you've already collected, right? Because you already have the correct prediction for the
Hmm.
model. So based on this prediction, you can maybe calculate some accuracy or something like that.
Hmm.
And this tells the model with how correct or how wrong it is.
And this it does on its own. We don't have to do anything. Like once you set up the algorithm itself, it just does it on its own.
Yeah, yeah. I mean, you're going to maybe set up how this kind of performance metric is calculated. Say accuracy,
Hmm.
then you say find how many are correct, how many are wrong, and then find the percentage correct.
Hmm. Okay.
And if you are going to use some other metric, then maybe you're going to define that metric.
Hmm.
But afterwards, it's going to do it on its own. It's
So
going to just,
from what I gather from that, it seems like all the human input is right at the beginning, and after that, it's all just the algorithm itself.
yes, yeah, yeah.
Yeah. So in cases where
Gotcha.
the human input that you talked about, right? So in some cases we may not know what are the parameters that are going to affect the output, right? So there can be cases where or situations where we ourselves are not sure what are the factors that are going to influence this output. We may have some arbitrary list of parameters. We don't know whether these are the parameters that are going to affect the output,
Yeah.
right? So in such cases, like how does it work? Like, does it learn new variables, or
Yeah, so there are certain models. Recently, neural networks and deep learning are more popular models, and these models have the capability to create their own variables, which are based on some patterns in your input and not directly just your input data.
hmm,
So
okay,
these can learn, say, some kind of pattern in your data and use these to make the predictions. So what you mentioned about learning its own parameters, that's what happens in neural networks. For example, you can think about the there was a there was a research from Google recently, not so recently, maybe a year back, saying that their translation model has learned its own language.
Hmm.
So that is basically
hmm,
some kind of parameters which it has learned on its own based on the
okay,
input that you've given it. So they trained it with sentences from different languages, and this model converts it into some other language which is understandable for the machine, and uses that as the intermediate language to do the translation. So in this way, it can
okay,
translate from any language to any language with just one model.
okay.
Whereas
Hmm.
earlier, it
So
required
this could
different models for each language pair.
Okay.
this could be something like a universal language if we learn or we figure out how to understand it.
I don't know if we can understand this because it's going to be,
Mm.
say, 1,000 numbers.
Okay, that
Maybe you can, Sujit. You're already living in the matrix.
So,
Probably you can.
Yeah.
i- so is it like the algorithm will break down the structure of language, the grammar, and all these things into some form that it understands, and then repurpose that into any other language?
Yeah, it's something like that. So, for example, you might have some sentence, say some example, give me some example sentence.
My name is Shreedeep.
Hari is living in Sweden.
Yeah, something like
Okay, my name is Srideep. So it's going to maybe create different representations for each word
that.
and some kind of representation to understand what are the relationship between the words. So you might have heard of this dependencies in a sentence. Like you can
Yes.
make a
Okay.
graph out of it by saying, okay, this word
Okay.
is object of this
Hmm.
word and so on.
Yeah. But
So it
okay.
has to learn some representation of this dependencies.
But what I don't get is in English. I get from English to something else. If you know English, you can do something, but you need to know all the other languages and how they work as well, right? Because in English, it's
Yeah,
subject,
so
verb, object, but it won't be the same in other languages.
yeah, so as long as you learn some general representation of this,
Hmm.
which is not based on the object and subject and so on.
Okay. And this understanding it does on its own. We
Yeah,
don't tell it
yeah,
what to do.
yeah.
Okay.
So, Hari, I remember reading some article related to this particular incident that you're talking about the common language. And one thing I remember from that article is that they mentioned that there is no identifiable grammatical structure where sometimes the sentence, if gets converted into something like I, it just reduces everything to
Mhm.
as little words as required. So that just reminded me of one scene from The Office where this character Kevin is just reducing the words he's using, and he's like, "Why use many words when
When
less word do job?"
that's become a
So
meme
is
now.
that yeah? So is it something like that when we look at what the algorithm is going to tell us about a sentence, like is our interpretation going to be something like that where we are like, why is the grammatical structure not there? Is it going to be like that?
No, so so once it reaches this common language, then it has to generate the output in whatever language you want, right? So it depends on how good that
Yep.
part of the model is.
Yes,
So
my
there
question
are
is
there are
more about
some.
interpreting the black box. So currently, whatever the model is doing, say, input is English, output is say in French.
Okay.
The conversion factor is like a black box right now. So when I try to understand it, is it going to look that kind of like funny to us or incomprehensible?
It's going to be a bunch of numbers. I mean, you can interpret it however you want to.
I mean,
Maybe you
also,
can take
yeah.
different sets of numbers and see which word is closest to these numbers and say, okay, I'm going to replace this set of numbers with this English word. And then, yeah, you're going to get some sentence, but it's not going to have much of a grammatical structure, or it's going to miss something, which,
Which is happening right now because something that I realized from Google Translate is you give a word in English, for example, there might not be an exact word for that in, let's say, Tamil. It might be something that's like it, but not exactly that. And then it'll replace it with something it thinks that it's most relevant.
mm,
But when we read it as a human, it's like, what is this? This doesn't make any sense. This happens a lot, and it's probably because it's not a human translating it because they don't know the context behind what the sentence is. It's just a sentence.
yeah. Yeah, but they are probably not having so much data for certain languages,
Hmm.
and that influences how good these models are.
Yeah.
Okay.
Okay.
And I think they are trying hard to collect as much data as possible.
Yeah.
For example, I think there is a Google contribute thing where you
Yeah.
can go and like validate some translations or add your own translations for
Yes,
some
there'll be like a
content.
tick mark at sometimes when
Yeah,
it's validated and stuff.
yeah.
All right, that was part one of our discussion on machine learning with Hari. Do like, subscribe, and all that good stuff. It really helps us out and helps the podcast grow. And talk to us on Twitter or Instagram if you have any questions or feedback. We'd love to hear from you. Take care and see you next week. Bye bye.